Hi, computerized accounting class. This will be the third part of our series. We're going to create an amortization table here. An amortization table takes a loan and breaks it up into its total payment, into its interest amount, and its principal amount. We'll walk through this. So we're going to start off here with the car loan, which might be typical for a lot of us at this age. The car we're buying is $24,000. That's the amount that we're going to finance. The interest rate we're getting on this loan is going to be 4%. And it's going to be for 5 years or for 60 months. So to start this off, we need to calculate our payment, our monthly payment. And we're going to try to use an Excel formula to do this. They should have one under financial. Let's see if we find one that says payment. PMT payment. It takes the rate, the number of periods, the present value, the future value, and then the type. Let's try this formula. Alright, we want the interest rate per period here. So it will be 4%, or we'll go ahead and refer to their table, the 4%. But that's a yearly rate, right? We want to convert this into a monthly rate, so it'll be that divided by 12. Number of periods, we'll go and refer to our table. Number of periods is the 60 different months in 5 years. Present value is going to be 24,000. The future value will be 0, right? Once this loan is done, the number will be 0. Alright, the type here, the payment typically is at the end of the period for most things, except for like rent. Rent's typically at the beginning of the period. But for finance problems, always assume it's at the end of the period unless the problem tells you it's at the beginning of the period. So we're going to go and put here 0 to represent the payments due at the end of the period. It only changes it by one accounting period. And we're going to get a payment there. I'm going to show you another way if you have a calculator. One sec. Alright, so I just pulled up a graphing calculator. My main objective here is just to check to make sure that Excel works. I usually don't use Excel. I'm used to this, to using a calculator for this. So we're going to go ahead and try this out. We're going to go under Apps, Finance, TMV Solver. Number of periods is equal to 60. The interest rate per period is going to be equal to 4 divided by 12. The present value of this loan is equal to 24,000. The payment we're going to solve for, and the future value is going to be equal to 0. And notice it's set to end already. And leave these two alone. We're just going to press alpha solve. Okay, and we get to 441.99. I'm going to show you that. Yeah, so it's materially the same thing, right? 441.99653. So it's just rounding in Excel. So I just did that to verify that Excel's calculating it correctly. You can use this as a graphing calculator if you have one, but I'm not going to assume every student has one. So Excel will do this as well for us. So we're done with that part. So this is a payment that's going to be going out every month for this loan. Alright, what do we want to do with this? We need to make an amortization table. We're going to keep track of the month. We need to keep track of beginning principal. Keep track of the interest payment. Let me go ahead and change this. Beginning principal. The interest amount of that payment. And then the principal payment. Center all this. I'm going to make all these rows a little bit bigger so it's completely visible. Alright, the month here we're just going to do 1, 2. We wanted to count down. I could count this down to 60 for all the months, but I want this to be in a table that's easier to read, so I'm only going to count this down to 20. But notice Excel is going to detect this pattern. 1, 2, 3 is going to detect it. Okay, the next number is 4. I'm going to take this all the way down to 20. And I'm just going to copy and paste this. I want this to show up again for the next 20 months and then the third 20 months. So I press Control C to copy it and then Control V to paste it. And I want to standardize all of these column sizes. Alright, and these I actually want to start at 21, 22, 23, and then I have Excel detect the pattern. It will start at 41, 42, 43, and we'll have Excel detect the pattern. Alright, so now we have all 60 months represented here. Alright, the beginning principal is going to be equal to the $24,000, the initial amount of the loan. Now when we make a payment, I'm going to go and write our monthly payment up here. Is equal to, let's go ahead and get it to show us some sense. Okay, it is showing sense, it's just rounding up. So it is actually an even 442. Alright, so that monthly payment, we're going to be paying our interest on the loan and then our principal payment. The interest is going to be equal to the amount of the principal times the interest rate. And that interest rate we're going to need to fix because it's going to stay constant at that row. So times that interest rate, but it's not all of that interest rate, it's that divided by 12. We need to convert it to the interest rate per period. And that should show us the amount of the interest payment for the period. The principal payment will be all of the rest, so it'll be equal to this number, 442. We need to fix it, minus the interest payment. Alright, so the total amount is $442 of the payment. $80 goes to interest. It's the interest rate divided by 12 based on the principal. I've set these up as formulas for a reason. Alright, our new principal then will be equal to our old principal minus the amount of the principal payment. So our principal will be going down over time because we're making payments to the principal. Alright, we set it up this way. Now we can just copy down the formulas. So we're going to copy this down. It's not going to make sense right now because we don't have all the other inputs. The interest is always going to be equal to the interest rate, which is fixed, divided by 12. So we're going to take the principal amount and times the interest rate divided by 12 to get the interest rate per period. Drag it down. Again, it's not going to make perfect sense yet. The principal payment is always going to be equal to the total amount of the payment, which is fixed. Absolute reference minus the amount of the interest payment. Once I drag this one down, it will work. Alright, so now we see the relationship for the 20 months. The principal is going down over time. The interest is also going down over time. That's because the principal is going down over time. And the amount of the payment is staying fixed, so the amount of the principal payment is going up over time on this amortization table. We're just going to continue this. We're going to have the beginning principal being equal to the old principal minus the principal payment on the 20th period. We're going to have the interest payment equal, we can just copy over this formula. We're going to make sure it worked right. So yeah, it's taking the beginning principal times the 4%, which is fixed, divided by 12. And then the principal payment, again, will be the same thing. We can just copy over the formula in Excel. If you just Control C here to copy it, and Control V here is copying over the formula, not the number. There is a pay special. If you go in here, there's pay special with values. I don't want that one right now. I want it to actually copy over the formula. And we can check to make sure it did it correctly. So it's dragging this one to absolute value, subtracting out the interest payment. So the total payment minus the amount we're applying to interest equals the principal payment. And now we can just drag down the formulas. Let's see. Yeah, I didn't like all three at once. Let's see what I'm doing wrong. Oh, because, no, okay, I gotta do this one different. So if you make a mistake, just delete it. Our new principal will be equal to the old principal minus the principal payment, and then I can drag it down. The interest payment should be the same calculation. The principal payment should be the same calculation, the total amount of the payment minus the interest. And again, we see the same thing. The principal keeps going down over time. The interest keeps going down over time. That's because the principal is going down and the interest is based on the principal. And the principal payment keeps going up because it makes up all the rest of the payment. We're going to do the same thing here. The beginning principal will be equal to the prior principal minus the principal payment. The interest amount and the principal payment we can both copy over. The new principal on this column will be equal to the old one minus the principal payment. And now we can just copy down all the formulas. Alright, so let's look at it. We got all 60 months represented. The principal is going down, 440.30. We had the final interest payment here. The final payment on an amortization might be off by a few cents because there is rounding going on. We're rounding this to the nearest cent. So mathematically you do lose some precision. Let's see what the ending principal is. So it's going to be off by 23 cents here. So effectively the last payment would just be reduced. So this last one we only need 440.30 of principal to cover. So our last payment then would not be 442.00. Our last payment would be 441.77. So it's off by what, 23 cents. If you're a consumer, you're probably not even going to notice that. It's going to be on direct deposit or whatever. But if you do notice that the last payment usually is off by a few cents to make up for that mathematical rounding. Let's see what else we can do to this spreadsheet to make it look a little bit better. We can call this merge and center, call this an amortization schedule. Or a car loan. We can make all this a blue color, darker blue, and we can make it white text, bold everything here. Let's add a border. Side border. Maybe we want a space in between here and here to kind of help the eyes realize it's different. And then if we want, we can do something a light color here. Alright. And then we have our amortizations done for a car loan. Again, this splits out every payment. The payment's going to stay fixed at $442, except for that last payment, which is going to be a little bit less. Or, yeah, a little bit less, 23 cents less. It could be a little bit more, a little bit less, but it's only going to vary by, 20, 30 cents in this example. But it shows every month of payment, 1 through 60. It starts with the beginning principal, and we see how that beginning principal works down over time until it eventually, if we did it after this period, you would see the 440, the prior period beginning principal minus the principal payment, it goes down to 0. It shows the total amount we're paying in interest. If we wanted to total this up in Excel, all we got to do is hover over it. Hover over all the interest payment columns. and Excel will total it up for us. The total amount of interest on this loan we're going to be paying is $2,519.77. The total principal payment should add up to the total value of the loan, so it should be the $24,000. You'll notice this also if you do a house. You notice at first most of that payment is going to be going to interest, only a small amount of principal, but as you get longer into the term of the loan, more of it's going to be going to principal and less to interest. Alright, I think that's it for the amortization schedule. I would look on Blackboard for your instructor to see what a similar assignment you're going to have, but I bet it's going to be something similar where they just change the variables here. But that should conclude it, and this should be the last part in this series. I've enjoyed working with you guys, and good luck in computerized accounting. Alright, see you guys next time. Bye-bye.